Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on expected value. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. Expected value seems to be a concept that gives students trouble, so this is a good video to help review the concept and topic. The expected value is the long-term average. We will refresh ourselves by repeating the formula for the mean, which is the sum of x times p of x. If a process is done over and over again, the mean is the long-term average. It is also called the expected value. This tells us that the formula for the expected value is the same as the formula for the mean, or the formula for expected value is the sum of x times p of x. The expected value is the long-term average. The mean and expected value are really the same thing. We use the phrase or term expected value when referring to a long-term average. Let's look at an example. A store is having a special promotion on a fan that regularly sells for $28. A customer purchasing the fan draws a discount coupon at random out of the box, then puts it back. In the box are 2 coupons for $10 off the regular price, 5 coupons for $6 off the regular price, and 7 coupons for $2 off the regular price. Each customer pays the regular cost minus the amount of the coupon drawn. Find the expected value for the cost of the fan and interpret the results. Pay attention to the directions. We are asked to find the expected value for the cost of the fan. This tells us that we are looking for the mean cost. So let's go back and figure out how much this fan will cost, or the different prices that this fan could cost. We have 3 types of coupons mentioned in this problem. And the original price of $28 that we will subtract the coupons from. We have 2 coupons that give us $10 off, 5 coupons that give us $6 off, and 7 coupons that give us $2 off. That will give us a total of 14 coupons in our box. Since we will be building a probability distribution, the best way to organize this information is in a chart or table. Notice that the X value is not the amount of the coupon, but the cost of the fan, since we want to know the expected value of the cost of the fan. So we will figure out the cost of the fan when picking each of the coupons. If you pick a $10 off coupon, you will pay $28 minus the $10 off coupon, or $18. If you pick a $6 off coupon, you will pay $28 minus the $6 coupon that you will subtract from your total, or you will pay $22. For the $2 off coupon, you will pay $28 minus the $2 you will save, or a total of $26. Now we need to figure the probability of paying each of these amounts. We will pay $18 when we pick a $10 coupon, and we have a 2 out of the 14 chance of picking that $10 coupon. 2 out of 14 gives us 0.1429, and Miss Borlaug rounded this to 4 decimal places. We have a 5 out of 14 chance of picking the $6 coupon because there are 5 $6 coupons. And Miss Borlaug rounded that to 0.3571. There is a 7 out of 14 chance of picking a $2 coupon because there are 7 $2 coupons, and that gives us 0.5. This completes our probability distribution for the cost of the fan. Now that we have this information and we have it organized, we can now compute the expected value, and we could use another column in our table. I need to pause here. Let me pause. Okay, sorry, I had to pause the recording there, and we will pick up right where I left off, I hope. But anyway, this completes the probability distribution for the cost of the fan, and we now have this information and we have it organized so we can now compute the expected value. We could use another column in our table to do this, but since we only have 3 rows, it is just as easy to multiply and add these values by writing them down, since we're taking the sum of x times p of x, by multiplying them and adding them down together here at the bottom. And that would give us 18 times the 0.1429 plus 22 times the 0.3751 plus 26 times the 0.5. We're multiplying the 18 times its probability, because 14.29% of the time we get an 18, and 35.71% of the time we get a 22, and 50% of the time we get a 26. So we'll add those values together, and when we add those values together, that gives us 23.4284, and since we're dealing with money, we'll round that to the nearest cent, which gives us $23.43. There is some rounding error here, but it's really okay. If we had kept the fractions and multiplied throughout with the fractions, 18 times 2/14 plus 22 times 5/14 plus 26 times 7/14, that would give us 164/7, which is still approximately 23.4286. Rounding to the nearest cent, we still get 23.43. And for our work, most of the time we do not need to worry about being that accurate. Lastly, we need to interpret the results. And basically here, remember, this is a long-term average. So if the fan is purchased over and over again, if our process is done over and over again, the average cost of the fan will be $23.43. We want to remember that the expected value is the long-term average. Also remember to ask yourself if your answer is reasonable. Does this sound like a reasonable price for the fans? Since the fans range in price from $18 to $26, $23.43 is a reasonable answer. Thank you for watching, and we will pause this first video here. If you are a Walters State student and need additional help, please stop by the Math Lab in MBSS 222.